Cartesian coordinate, you know what that is. Just graphing ordered pairs. Distance between 2 points and midpoint of the line segment. Basically, we're going through that. But then there's a couple little more challenging problems to deal with this as well. All right, distance formula in the coordinate plane. All right, this is your formula right here. So I think it says D equals on your right there in the middle. Put that down. Now I don't necessarily need to say D between P and Q. You can just put distance equals and x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now you see that figure there over on the right? Okay, for you, all this is the Pythagorean theorem. Okay, this is your Pythagorean theorem because you talk about a squared plus b squared equals c squared. C is your hypotenuse, which would be the distance between P and Q. To get your A or your B, it doesn't matter. It's going to be the difference between your X values. Okay, it's just going to be that horizontal leg. Okay, so you start your point, you draw one vertical, you draw the other horizontal, they meet at a right angle. Your vertical leg is going to be the difference of the Y values. Okay, that's all it is. Now, all they've done here is that the C squared, if they've taken the square root to get C. Okay, so that's all it boils down to. Okay. We got to make sure you can find the distance between 2 points. So you get the 2 points. -2, 5 is the first point. Q is 3, -4. Okay, for that second point. And then it's just plugging in. Since we got the formula, we can just plug that in. It doesn't matter which one you let be x1, y1, x2, y2. So distance equals the square root of, and I do the second one minus first, but you don't have to. 3 minus -2 quantity squared plus -4 minus 5 quantity squared. 3 minus -2 is 5. -4 minus 5 is -9. Make sure it's in parentheses when you square it. What do we get underneath the square root? Andrew?
106.
106. We always want to check to see whether it will simplify. Okay, you do want to do that. Okay, so take a second so you can figure out whether that will simplify. Let's record. All right, does it? No, it doesn't simplify. Because 106 is 2 times 53. You should be able to divide it by 2. But 53, you get stuck. 53 is prime, right? Anybody find anything goes into it? I don't think so. We're stuck. So you can leave it like this. Now, in some cases, they'll want the decimal. So the square root of 106 is 10.3 approximately. 10.3. So it just depends on how they ask the answer. Now remember, exact answer means no decimal. So you have to leave it as radical 106 if that's what they ask for. Distance formula, plug that in. All right, let me go back for a second. Not that you have to, but you got to understand, if you drew this out, -2, 1, 2, 3, 4, 5. There's that point, and then 3, -4. Really, we're using, again, the Pythagorean theorem. You're connecting those points. You draw a line straight down. You draw a line straight across. It's not a very straight line. Let me see if I can make that one a little straighter. You got the right angle. This here, 3 minus negative 2, gives us the horizontal leg, which is 5. Okay? And then the negative 4 minus 5 will give us that leg here. It gives us a negative, but when we square it, it becomes a positive. So basically, you're doing Pythagorean theorem. 5 squared plus 9 squared. Okay, you get 106. Always going to work. Do you have to draw it out? No, you can use the formula. All right, midpoint. That's just the average of the x's, average of the y's. Okay, add the two together. x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. It is an ordered pair. Distance is a constant. Distance is a value. It is, units, feet, inches, meters. Midpoint is a coordinate, x and y coordinate. So you just want to get halfway in between your x's, halfway in between your y's. Okay. All right, find the midpoint of the line segment joining the points P, negative 3, 6, and Q, 1, 4. Okay, so midpoint, you're going to add your x's, negative 3 plus 1 divided by 2. We're going to add the y's, 6 plus 4 divided by 2. That gives me negative 2 over 2, which is negative 1. 6 plus 4 is 10. 10 divided by 2 is 5. So negative 1 comma 5. So that'll be our midpoint. All right, now I expect you to know how to do that. Here's where it gets a little bit trickier. All right, find x. All right, read through that. That little line here on the left-hand side, I can't get that off of there. It's not supposed to be there. It's a mistake. So don't draw it in there. Okay. You can draw in the point 3, negative 2. I don't think it's on there, is it? No. Okay. All right. Big thing. Do you understand the scenario? What it's asking? Could you draw out the situation? Could you find a point, x2, that is 5 units from 3, negative 2, or could you come close to figuring out where that point is? Okay. So it has to have a y value of 2. Okay. So it's going to have to lie somewhere on that line. Okay? Can it be straight up from that point? No, because if you go straight up, what's that distance? That is 1, 2, 3, 4. If you go up 5, you're not on that line. How many points will be 5 units from that point? 2. Be 2. 1 to the left and then 1 to the right. Now when we solve it, it'll naturally find both of them. Okay, all right, now how do we figure it out? So there's some point. There's some point over here where that distance is 5. Okay, that's what we're looking for. What are the coordinates, or how do I represent the coordinates of that point? You represent this point as x comma 2 because we do not know the x value. This point we know it's 3, negative 2. So use your distance formula. So I'm going to use my distance formula. Let me just write that down in general. Distance equals square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, we know the distance. We want that to be what? 5. I'll put it here and say, I want the distance to equal 5. I know one of the points is 3, negative 2. I'm going to represent the other point as x comma 2. Now just substitute into the distance formula. And sometimes you just got to do that. You don't know what's going to happen. You just got to try something. See what happens. Sometimes you might have a pretty good idea what it's going to look like. Other times you just got to go with it. So 5 will go in for the distance. X2 minus X1. I'm going to make this X minus 3. Okay, I got to have, I don't know what it is, so I'm going to call it X. X minus 3, quantity squared, plus 2 minus negative 2, quantity squared. That's solvable. Okay, that's solvable. Now, how can I get rid of that radical? I don't want that radical in there. Square both sides. Okay, square both sides, you'll get rid of the radical. So it's going to be 5 squared equals square root of this whole thing. And 2 minus negative 2, that's just going to be 2 plus 2, which is 4. And then quantity squared. All right, so what do I get? I get 25 equals X minus 3 squared plus 16. This is acting up on me a little bit. All right, I want you to think, how would you proceed? You got it. There's honestly a couple of different ways. How would you proceed from here? Matthew?
I'd subtract 16,
Okay, and then do what?
then I'd equal square root.
Okay. I like what he's doing, and that's probably the easiest way. Most people, though, what was the other option? Anybody think of doing something else? Foil. Okay, I'm going to foil. Matthew, you do it like you want. You're saying that's fine. I'm going to foil because most people think of it that way. Okay, that's just kind of what first comes to mind. Both ways will work. Matthew's is probably a little bit quicker, but I'm going to foil as well. And so when I foil, I get 25 equals X squared, and I'll actually go back and show you what he was talking about. Minus 6X. Let me do this. Minus 6X plus 9 plus 16. And so I get 25 equals X squared minus 6X plus 25. All right, what are you thinking here at this point? Where we're at? I got an X squared. Is it going away? Nope. So I'm thinking set it equal to what? 0. So subtract 25. Now something happens here. You think it's a bad thing, but it's actually a good thing because 25 minus 25 is 0. I get 0 equals X squared minus 6X. That factors. What do you got to do? Just take out what? X. Take out an X. And so I get 0 equals X times X minus 6. And so X equals 0. And then X equals 6. We said there's 2 points. Those are going to be your X coordinates. What's the Y coordinate for both points? 2, right? So look up here. Now, I didn't draw it in the right spot. So 0, 2 would be this point right here. There's 0, 2. That's one of my points. My other point is 6, 2. And I'm saying that both of those distances are 5. 5. Now this one works out really nice, not all of them will, because you remember from geometry, or I didn't even know, remember, right triangles, Pythagorean triples, they're all whole numbers. The most common, I don't know if it's the most common, but the smallest right triangle with all whole numbers is a 3, 4, 5 triangle. So you probably could have figured that out if you went up to here and then you went over and you said, oh, this is 4. If I go over 3, then that has to be 5. But both cases work, 0, 2, and 6, 2. All right, let me just show you real quick what Matthew's talking about because it really doesn't matter. 25 equals X minus 3 squared plus 16. He said subtract 16, and I get 9 equals X minus 3 squared. Well, this goes back to your completing the square, how we did that. What would you do now? You got something squared. Take the what? Square root. But you got to make sure this is plus or minus 9, or square root of 9 equals X minus, or square root of X minus 3 squared. This is that. So that gives me plus or minus 3. That's a 3. Equals x minus 3. When I add the 3 over, let me just write it as x equals 3 plus or minus 3. We still get 0 and 6. Biggest thing is people forget to put the plus or minus. Okay, that's the biggest mistake people make. But you still get to both answers. Either way works. Like I said, the way Matthew saw it might be a little bit quicker. All right, you got one other one there. Or we do. Find the point on the x-axis that is equidistant from the points negative 3, 6 and 8, 3. What does equidistance mean?
The same distance.
Same distance. Not everybody knows that. Okay, see if you can I want you to estimate where it's at. I want you to estimate where it's at. Now, this is not the midpoint. There's a point on the x-axis that'll be the same distance from both points. So your point has to be on the x-axis. You tell me where what the x value is. You estimate it. You estimate it. Carter, what do you think?
I think the x value is 1.
He says 1. Let's just say, is it reasonable? That's all we got to do right now. Is it reasonable? And so right now, do those distances look at least relatively close?
Mhm.
All right, good. So that's reasonable. So it should be around there. Now we got to prove it. We got to prove it. And we're going to prove it algebraically. Well, it is actually not 1. It's close to 1, but it's not 1. This is the point, negative 3, 6. This is the point over here, 8, 3. How can I label that point there? You can't say 1, 0 because that was just an estimate. So how do we label it?
X0?
X0. We know it has to have a 0 for the y-axis because it is, or for the y-coordinate because it's on the x-axis. All right, this is d sub 1. This is d sub 2. We need to show or find where d sub 1 equals d sub 2. The distance for 1 is the distance between the point negative 3, 6 and x0. The d2 is the distance between 8, 3 and x0. So you're going to use the distance formula on both of them. So the square root of x minus negative 3, which you can just write as x plus 3, squared, plus 0 minus 6 quantity squared, equals, we want it to equal the other distance, which is going to be x minus 8 quantity squared plus 0 minus 3 squared. Okay, so we got an idea. We set the distance equal. Question is, how do you proceed? Once you get to this point, you got an equation. Sometimes you get hung up on the algebra. I'd get rid of the radical by doing what? Square both sides. Square both sides. X plus 3 quantity squared. Now that's going to give me a plus 36. You can go ahead and do that. And then that gives me x minus 8 squared. And some of you might have already foiled. Plus 9. All right, we can't do like Matthew said in the last one. I can't get x plus 3 squared because I got another x minus. You do have to foil. We got to foil. We got to simplify. Okay. On each side. So when I do x plus 3 squared, that gives me x squared plus 6x plus 9 plus 36 equals x squared minus 16x plus 64 plus 9. And I'm just going to combine those constants x squared plus 6x plus 45 equals x squared minus 16x plus 73. All right, again, you can, all right, how do I proceed? Where do I go from here? Where do I go from here? We've done all the algebra correct. We don't have any issues. Sometimes you kind of get hung up here. Dakota, how are you proceeding?
Did you set one side equal to 0?
Possibly, but think first. And that will work. That will work. What's going to happen with our x squareds?
Cancel.
They're going to cancel out. So I'm not going to have an x squared, which typically means I'm not going to have to factor. So I'm going to take care of that first. So go ahead and just subtract an x squared. And that gives me 6x plus 45 equals negative 16x plus 73. You don't have to set it equal to 0 because you don't have an x squared. Just get all the x's on one side, all the constants on the other. Right? Good old-fashioned linear equation. I'm going to add 16x. I'm going to get 22x plus 45 equals 73. And I'm going to subtract 45. And I'm going to get 22x equals 28. Now it's not going to divide in there evenly. Go ahead and just keep it as a improper fraction. It's fine. I don't need a decimal. And then reduce it though. Reduce it. Divide by 22. Divide by 22. X equals 28 over 22, which becomes 14 over 11. Agree? Is that pretty close to 1? Yeah, Carter was real close. Okay. But more often than not, it's not going to be exact. So we've showed, you've proven that that's the x value where both distances will be the same. Okay. So you'll deal with more problems than this and just finding the distance and finding the midpoint. I know you guys can do that. All right. Good Friday lesson here for you, Matthew. So you can get your homework done so you don't forget it.
I did it.
You did this already?
No, I didn't. Only the last time.
Oh, okay, good.
It's not minimal diffusion.
No, it's not minimal. Okay, so there's this assignment. Go ahead and get to work. Get as much done, if not all of it, before you get out of here. Get through all of it.
Really?
You have to be efficient.
A lot of it.